Okay everyone, here is now our lesson for today. We are going to discuss sets and the real number system, but let us first focus on sets. And I hope after our discussion, you are able to define a set, a universal set, and the cardinal number of a set. Also, you are able to illustrate a well-defined set, universal set, and cardinal number of sets. And finally, value things around you. Now I want you to look around you in your house. See if you can find things similar to what I am going to present this time. Okay. Do you find this in your house? Or maybe in your neighbor's house? And what do you call this? Okay, we call this a sala set. How about this? Do you find this in your house? Or in your friend's house? Or in your neighbor's house? And what do you call this? Yes, it's a dining table. How about this? Okay, you're correct. This is a set of toys. And this one, this is a set of colors. Now what about this? Okay, this is a set of eating utensils. And this one, yes, you're right, a set of teeth. We have been mentioning the word set. So what is a set? A set is a well-defined collection of distinct objects or numbers. And I would like to emphasize on the term well-defined and on distinct. Now let us take note that the arrangement of the objects in the set does not matter. Okay, so as we progress, we will know later why the arrangement of objects in a set does not matter. Okay. And what is meant by the expression well-defined? Now let us see this one. Okay. Of course, we have identified this one as a sala set. And what makes this identification of set a well-defined one? Okay, because of the word sala. Okay, the word sala makes it a well-defined set. And how about this one? Okay, what makes this set a well-defined one? Yes, you are correct. Because of the expression or the description, which is dining table, which makes it a well-defined set. Now, what about this? Okay, what makes it a well-defined set? Because of, correct, toys. Okay, how about this one? A set of colors. And what makes it a well-defined set? Because of the word or description Yes, you're correct. Colors. Now what about this? You are correct. Eating urine cells. And this one? Yes, teeth. A set of teeth. The word teeth makes it a well-defined set. Okay, let us go back to our definition of a set. A set is a well-defined collection of distinct objects or numbers. Now let us emphasize on this term distinct. Okay, and we are going to identify the distinct objects that compose a set. So let's start with our example on Sala set. Okay, we call that as the individual chair in that Sala set. Another is the long bench or the long chair of the Sala set. We also have that center table. These three are the distinct objects that compose a Sala set. Now, what about this set of dining table? What can you identify? Okay, what distinct object you can identify? I don't hear you. Okay, so what is one distinct object that you can identify? Okay, correct. We have the dining chairs. Okay, now what else? Okay, you are correct. The dining table. These two distinct objects make up a set of dining table. Now what about this? In a set of colors, what are the distinct objects that you can see or you can identify that will make up a set of colors? Name one. Okay, let me give you one example. Okay, shade of blue. Actually, under the shade of blue, there are different distinct shade of blue. We also have a shade of green. Under the shade of green, we still have distinct colors. I mean, distinct colors of green. What else? Okay, we have shade of red. What more? A shade of yellow. Okay, one more. Shade of gray. Now I think we can still identify other shade of colors. Okay, but let us end up to this 5 only. Okay. Now here, I want you to discuss with your family the different or the distinct objects that you can identify from this set of eating utensils. Okay, I am giving you 30 seconds to identify the distinct objects in this set. Okay, so I hope you have discussed your list with your family or even with your friends. Okay, now what is a universal set? Okay, so we are now in the universal set. Now, a universal set which is denoted by a capital U is the set that contains all the elements of the other set under consideration. Okay. Let us go back to this example of a Sala set. Now, this Sala set, as we have identified earlier, one distinct object in our Sala set is an individual chairs. Okay. Another is actually we can consider this as one group of object. Another is we have the long bench. In the same set. Another is the center table, again in the same set. Putting them together, we have a Sala set, and actually we call that as a universal set. Okay, we can consider our Sala set as a universal set composed of a center table, a long bench or long chair, and an individual chair. Now let us try to consider this illustration. We have here a set A consists of objects like 1, 3, 5, 7, 9. Okay. Another is we have set B. Consists of numbers 2, 4, 6, 8. And let us try to have a set C. Now as you can see, in the set C, there is no object inside the set. And we call that as a null set or empty set. And what is null set or empty set? It is a set that does not contain anything or no element inside it. And it is denoted by the symbol. Okay, by that symbol. Okay. Now, let's look at here. Okay. We gather or we combine the elements in set A and set B. So from the elements of set A, we have 1, 3, 5, 7, 9. And for set B, we have 2, 4, 6, 8. The new set that is formed is what we call a universal set, denoted by the capital letter U. Okay? Okay, let me repeat my discussion on this example or illustration of a universal set. We have here set A composed of 1, 3, 5, 7, and 9, and another set B composed of 2, 4, 6, 8, and another set C which has no object inside it. No? Okay. So this is actually the set notation, and this symbol is actually, we call this as braces. Okay. Now there is nothing we can see inside the set or inside the braces, but still that is considered as a set. So we call that as, again, we call this as a null set or an empty set. Again, how do we define an empty set? It is a set that does not contain anything or no element inside it, and it is actually denoted by this symbol. Okay, now if we are going to collect objects from set A and combine it with the objects in set B, the resulting set is the universal set. Okay? Let us proceed to the cardinality of a set or cardinal number of a set. Again, let us consider set A with these objects inside or numbers inside. And what is an element of a set? Okay, an element of a set is any object contained in a given set. So for example, in this set, the elements are 1, 3, 5, 7, and 9. Again, 1, 3, 5, 7, and 9 are the elements of set A. Now, there are how many elements in set A? Let us count. 1, 2, 3, 4, 5. There are 5 elements in set A. So what is the cardinality of set A? The cardinality of set A is 5, which is denoted by this symbol. Okay, again, the cardinality of set A is 5. Now let us try to have another example, this time set B. Okay. There are how many elements in set B? We have 1, 2, 3, 4. There are 4 elements in set B. So what is the cardinality of set B? The cardinality of set B is 4, which is denoted by this expression. Okay, now let us try to consider set C, which is an empty set. There are how many elements in set C? Yes, there is no element in set C. And what is the cardinality of set C? Correct. The cardinality of set C is 0, which is denoted by this expression. So what is a cardinality of a set then? Okay, the cardinality of a set, meaning it is the size of the set or the number of elements in a given set. Okay, so here we are now in this let me do it myself part. So I want you to answer the following examples by yourself or with your family, with your friends, with your brothers and sisters, and or you discuss with them. Okay, so here is now example number 1. So given the following sets, set A composed of elements W, O, and D, set B, set C. So what you are going to do is to determine the cardinality of each set and determine the universal set of the above sets. C. Determine the cardinality of the universal set. I am giving you 1 minute. Okay, time is up. Okay, so I hope you have discussed with your with the people that surrounds you or with the people around you. Okay, so let us check your answers. Okay, so letter A, the cardinality of set A is 1, 2, 3, 4. So 4. Set B, the cardinality of set B is 2, and the cardinality of set C is 3. And the universal set U is equal to the set composed of elements W, O, N, G, D, E, R, F, U, L. Okay, that's the universal set. And the cardinality of the universal set is 9. Okay, actually, if you're going to add the cardinality of each set, 4 plus 2 is 6 plus 3 is 9. Okay, so I hope you get the correct answers. Now let us proceed to this time we have the let me do it myself number 2. Given the following sets A, B, and C, where set A is an empty set, what you will do is you determine the cardinality of its set, determine the universal set of the given sets, determine the cardinality of the universal set. Okay, I am giving you again 1 minute to answer the problem, starting right now. Okay, time is up. So I hope you have discussed with your parents, your friends, your brothers, your sisters. Okay, let us now answer. So the cardinality of set A is 0 since there is nothing inside the set. The cardinality of set B is 1, 2, 3, 4, 5, 6. And the cardinality of set C is equal to 5. Now, for letter B, I want you to pay extra attention on this, the universal set. Okay, the universal set is composed of elements S, T, A, Y, E, G, F, R. Why so? Because S here is a common element of set B and set C. So we do not write 2S anymore. Instead, we only write 1S. Why? Because in our definition of set, it says that each element of a set is distinct. Okay? Since S and S are the same, so we write only 1. Another, A is a common element of set B and set C. So we only write 1A in the universal set. Another is E is a common element of B, set B and set C. So we only write 1E. And of course, the rest of the elements in set B and set C. Okay, so I hope you got it, you get it correctly. Now, the cardinality of the universal set is equal to 8. Now actually, if you are going to add 6 and 5, it is 11. But since there are 3 elements which are common to both sets, we subtract 3 from 11. That's why we get 8. Okay? So I hope it's clear to you how we get these answers. Next, I am going to ask this question. What is inside you? So in this activity, you are going to name any 2 sets of things in your house. Any 2 sets of things in your house which we have not which I have not mentioned in our discussion today. Any two sets of things in your house. The next, answer this question and discuss this your answer with your brothers, sisters, parents, or friends. How do you show care to the set of things that you own? Okay, so I want you to answer this one and discuss this with the people around you. Now, let this be your bonding moment. Okay, so we are actually ending now our discussion. And before I end, I want you to remember these words of access rave. Okay, or the words of Emilito Gallegos. What matters in life is the life that matters. Thank you. Okay, so that's it for today.